age assurance strategy lead for over 6 years, and we're going to hear your perspective on these issues. Thank you.
Perfect. Thank you, everyone. So I wanted to start with talking about this presentation is going to be the perspective of technology providers in the age verification world. There's a lot of different parts in the age assurance cycle. You have orchestrators, you have technology providers, or like people that make the technology in the companies, right? And I want to give the perspective of the challenges that actually someone that builds tech has in this area, rather than puts together solutions how to solve these problems. So 3 years ago, no user was worried about showing the proof of age online. No AI could produce a convincing fake face immediately, and no government had basically banned an entire group from social media. I mean, we all know this is different now. And the reason I'm showing this is because these changes are happening so fast. I think this is the first time that we face such a volatile and fast changing industry in government and in policies. So I'm going to talk about 4 different factors that is important for technology providers in this industry. The first one is like what actually good age verification providers required. The second is going to be the forces that push the market to be dynamic and fast responding as a technology provider as well. The challenges that age providers face to respond to these forces. And finally, how Incode we are responding to these forces. Okay, so the 4 key pillars that every single age technology must have to be efficient and to actually work is accuracy, meaning your solution is no bias, your solution actually works. Your age checks have fueled by good technology that gives you a right result. The second one is integrity of that result, the integrity of that age check. You can have the best technology to provide an age estimation, an age verification, but if that technology is really easy to be spoofed, really easy to be tampered, then loses all its value. The third one is privacy, right? There's different levels of privacy that this technology provides. And it's a super unique industry because privacy is such a core that brings with challenges as well. And finally, another really key factor here is the performance. When I talk about performance, I talk about this technology has to be good, has to be safe, secure, but at the same time has to be easy to integrate, easy to work, easy for the users to experience. So all these 4 factors are not static, they're dynamic, they're constantly changing. And that's a key challenge that we as technology providers face. So why these pillars are not static and why they need constant update, constant changing, especially in an industry that changes so fast. So I'm going to go through the 3 main forces that actually cause change in the age assurance world for technology. So the first one is regulation, and we all know about this, and all the regulators are here. But the reason is because, I mean, right now, 30 different markets have enacted regulations about age verification. But right now, we don't have really like a core, like in financial services or anti-money laundering or in health, for like in the US and HIPAA, that follow the same categories. So a platform can comply today, but in 18 months cannot be compliant anymore, right? The second one is age fraud. And this is actually something that is really, I think needs to be more, we as providers and as orchestrators, we need to be more worried about. So AI has turned basically age fraud and impersonation attacks in something extremely cheap, extremely fast, and extremely accessible to anyone. So the fraud that you're facing 3 months ago is not the threats that you're facing today. So technologies that are ready for fraud that happened 2 months ago, the next month, this technology has already developed to actually spoof those challenges, those measurements that you have to face that. The third one is the public opinion, and this is actually really interesting. So your solution can be fully compliant, but the expectations of the users and what they require that completely change the whole solution. So one story can rewrite the industry standards overnight. And we all seen, especially with privacy. And I'm going to talk about that topic a little bit later. So the first one is the growing regulatory landscape, requires solutions that can adapt and respond fast. Just to give you some perspective on what I'm talking about. In Incode, we work with financial services. Like we work basically with most financial services in the world. You may be probably working with them. So we're really experts in identity technology for those financial services. So in the past 35 years, there's only been 6 major changes in financial regulatory landscapes. Major ones, like for example, the FATF, right? And all the different countries follow a similar standard. So to give you an idea, in the last 3 years, there's been more than 40 different regulations and enactments about age verification. and they all don't really share a specific core. They have different technical requirements, they have different methods permitted, they have different privacy practices. So this is becoming really complicated for technology providers and orchestrators and companies to comply with. The second is the fast growth of AI powered by identity fraud. It really requires to be ahead of the fraud that you're facing in these technologies. So this is a graph in 2020. To create a deepfake image was about $1,000. Now it's under $1 and it's immediate. We're talking about deepfakes, morph activity, 3D mask. It's becoming really accessible to anyone, any age group, and any country. So this is a real risk that we are not taking into account. So just to give you an idea, this is our CPO. You can just go to anyone's LinkedIn, put it on something super accessible like Gemini, request Gemini to create a video, a deepfake attack, video of the person. And then now we have created a video literally in less than 1 minute. You can see there's a video where we are trying to prove liveness. And now we go internet, we buy a jailbroke phone, really easy. We inject that video that we just made into the jailbroke phone. We inject it into the camera. And then most solutions that you ask for age estimation right now, poof, we solve we fake liveness. So we can spoof liveness and a person over 18 really easily. And that can be done by a teenager really easily as well. And we have spoofed a lot of solutions because we tried to research this, right? So this not only goes for faces, and I think a lot of people focus on faces. Documents are really easy to generate today with Gen AI. So here, for example, you can go online. You require the quality of the fake ID that you want. They're made in seconds, and they have the same capabilities. So anyone can have a whole process of identity verification through fake documents. So the third problem is challenge is the public's opinions, and that actually shapes the solutions approaches. I mean, we all heard about the privacy concerns that the industry is going through, and right now these are some metrics of like the users. Even though there's a lot of security measurements, how scared they are of companies being trustful about how their biometrics are being used. So even though there's encryption, there's a lot of different regulation to ensure that this is happening and is secure. Users have to trust the companies. They don't trust the companies in this industry right now. Financial service, sure, I have an incentive to create a bank account. I don't know, a social media, an online gaming is the same incentive. Do I really trust this institution to give my data, even though they're telling me they're not doing anything with it? So and we've seen the flip running the market, everyone going for privacy solutions, even though it's not in the legislation. So how to select the right age technology provider that is ready to actually move and respond to all these different challenges? So the first one is your technology provider needs to control its technology, and its orchestration has to be flexible enough. So the reason is because when you change a new regulation, change public opinion, if you work with someone that actually owns the tech and is able to iterate the tech and innovate the tech live, that really makes a difference. The second one is the ability to continuous learning and adapting and evolve the technology. And this is super hard because we live in an industry where data needs to be deleted after it has verified. So a lot of times you already face the fraud and you don't have the proof that you face the fraud and you were exposed to fraud. So you cannot really learn. And I'm going to talk about how we do that in Incode. And the third one is the ability to innovate and to scale from the architecture level. Innovation can be, from the orchestration level and doing a lot of different things, putting things together. But when you're able to actually innovate in the root, that can really be a differentiator. So the first thing that how we solve this problem is basically we own our entire technology stack. So we have been working for the past 10 years in all the different industries in the world. We work with the major financial banks in Brazil, in Mexico, in Australia, in the UK here as well. And we develop everything in-house. So from passive liveness, facial recognition, ID validation, deepfake defense, age estimation, device and behavioral signals, everything is being enhanced during 10 years constantly. Now, the technology fueling age assurance must have the same quality and be as dynamic as the tech used for other industries. So right now we have this idea that financial services, healthcare, and other industries require a higher level of tech. We in Incode, we have the same technology that's fueling all these high industries. Is the same technology that's fueling the age assurance use cases and our age assurance clients. And all of this with the core principle to actually stay loyal to privacy. So how we stay loyal to privacy? So Incode outside of age assurance, we have, for example, last year we did 7.1 billion trust checks. We are working right now with the top financial services, the top entertainment companies, the top retail companies, the telcos, the travel, the government. I won't mention them, of course, but you can imagine which ones I'm talking about. But which this means is that all these companies have an interest for us to keep improving our technology because we're cutting fraud. We're cutting. We're making a more safer, a more trustful environment. And the good thing about this is companies in the assurance world that need to delete the data, they need to keep privacy, they benefit for this technology improvement and solutions. So the fraud that we see, and I'm gonna give you an example, the fraud that we see in Brazil, for example, is fraud that in 2 months is gonna be appearing in North America. That's how we learn. So we catch the fraud, we analyze from different perspectives, the face, the document, the device, the behavior, the environment. We gather those patterns, we check the fraud patterns, we put them together, and then we learn. So the next time we face that specific fraud, we actually are ready to stop it. And this is, we work in really high fraud environments, let's say India, Brazil, Mexico. And it's really interesting because a lot of the fraud is born in those regions. Then we're ready to stop it in the next one. And again, just to repeat, this is outside of age assurance use cases, because we do have the compliant permission to learn from this data. And I'm going to give an example for age estimation specifically, because I think we have a key differentiator of how we evaluate age estimation. So in the last 2 years, we have been doing 65 million age checks outside of age assurance for age estimation, sorry. We use age estimation in fraud and for financial services. So we do something called age discrepancy. So when you onboard to a bank, if you stole data and you create a fake ID, we're able to do an age estimation on your face, compare against the date of birth that you're claiming to have on your ID, and via discrepancy. If the person is saying they're 28 years old, it's estimated to be 20 years old, but the ID says they're 50, 65, most likely it's fraud. We actually got a prize in Colombia to make one of the biggest banks to get their fraud to zero with this technology. So we use this age estimation technology in most of major banks and financial services that we work with as well. That gives us the capability to be able to have really deterministic data of how good we're doing with age estimation. Right now, it's really hard for other companies as well to have an objective benchmarking of their data because they have to go through NIST, other institutions to get a result. We have the results. We know exactly how we're doing, and we know exactly where we need to improve. Of course, challenging because this is for over 18, but still, that makes the age gating use cases really easy for us. So the advantages is like we have a benchmark models performance because we have the face age estimation result versus the date of birth. We train the models with this data to keep improving our age estimation technology constantly. And finally, the data is way more diverse. Why? Because we're not using age estimation only in countries that require age assurance policies. We're doing everywhere around the world where we do identity verification. So actually, our biases are way better because we are facing faces for every single human in the world, basically. And this is not possible in data assurance alone. Why? Because all the privacy regulations that we have, they're important as well. But as I mentioned, we do think that is required, or not required, but we do believe that the age companies or the companies that require age verification, they should benefit from this as well. This is not only for the big financial services, why we cannot have the same type of technology. And this has led us to a lot of different results, right? And I'm gonna talk a little bit deeper about something that we worked on. So we are really proud of the technology that we built. We tested, we benchmark it, we send it to third parties to make sure that is working. We face constantly the newest of the newest in fraud. And even though we cannot really analyze it that's happening in age estimation, in age assurance use cases, we're ready for it. We use the same technology, regardless if our clients say like, no, I just want to have liveness. No, our core technology is to have this type of age integrity in age estimation checks. So I'm going to touch into a new challenge in how we're approaching privacy and how we're approaching on-device stuff. So Before I jump into that, we all know that device technology in age estimation can be challenging because you cannot really iterate or keep improving. And sometimes when you do age estimation on device, you have to face challenges with trade-offs. A lot of times you have maybe a good technology on device to estimate, but then your quality for security is really bad. So anyone can spoof it. And we all have seen that. So how can we keep it the same level of security and at the same time the same level of accuracy, the same level of performance, being fully safe, being fully secure, fully private? That's something that we actually want to explore more and to deploy. And we are launching a new solution. So these capabilities I just mentioned, having the product in-house, having the learnings from like a company that has scaled around the world, and also having half of our team being engineers, it's really interesting. A lot of age assurance companies or age verification providers, they either divide their teams into lawyers, product people, marketing people. We feel really proud that more than half of our team are engineers, basically. And you can guess why with all the technology that we developing has. But we are basically doing a new solution called zero knowledge age estimation. The difference here is that we understand that the users, it will take a long time for them to trust this industry. It's going to be really hard to push, even with all the PR and with all the education about what's happening in the data. The solution that we are thinking is the best, or that we're sure is the best right now, is like, you don't really need to trust us. Let's just make it architecturally impossible for us to access your face, for example. So we're creating, the first iteration that we're doing is for age estimation, meaning that we have two different types of approaches. We were able to do a full on-device hybrid solution, meaning that all the machine learning models that we are facing or are analyzing, computing the face, stay in the device, but all the data, metadata that are no PI and not required for face analysis are going into server to analyze if there's any type of injection attack, if there's a bot attack, if there's any type of other results that can temper the result of the age estimation. That makes fully private on device. Nothing is leaving really the device. The second approach, and the one that we're really excited, and tomorrow we're going to have a session on detail about these two solutions, more than welcome for everyone to join, is on homomorphic encryption. So what does homomorphic encryption mean? Going back real fast to this, we don't really want to sacrifice this type of technology for privacy. So how can we keep models updated, still learning, and at the same time having the capability to have full privacy? Homomorphic encryption, what we're doing right now is we're encrypting the face of the person in the device, and we're putting the encryption key in the user device. Then we train our models to be able to compute on encrypted data rather than raw images. The advantage with that is that Incode is unable by architecture or our clients to actually decrypt that face. We just get the encrypted information. And then the other advantage with that is that all the different models that we have created for these 10 years can be trained to actually read encrypted data instead of the face, right? So this gives us two advantages. We are truly committed to privacy. We cannot access the face of the user, and the user doesn't have to trust us again. There's going to be a challenge to educate the user what's actually happening. If I'm a user and I'm not educated and someone tells me, oh, no worries, this is homographic encryption, I'll be like, what? We are going to do that as well, of course. But at the same time, we are having all the benefits of innovation that we're constantly doing. So these are the two approaches to give us basically what we wanted to do, which is build privacy and innovation to drive trust. Thank you, everyone. I appreciate it.
Very interesting. I've read a lot about homomorphic encryption, and that is very common, as you said, in the financial sector, in the banking world, because it's not the heavy kind of encryption that is unbreakable and reversible. You can still read stuff that's going on in there. Anybody got a question or a comment? Where is your company based? Are you based in Mexico? Or?
No, we're based in San Francisco.
In San Francisco, right.
We have offices in London, Serbia, Barcelona, Madrid, Tel Aviv, Mexico City, New York, in headquarters in San Francisco.
Got it. Yeah. We're a global company, right?
Yeah.
So any comments or questions?
Okay, so I'm not an age verification, age assurance expert. I'm a scientist working with children, young people, and adults who may have learning difficulties, neurodiversity, etc. I'm only here today, so I missed yesterday's. I'm not going to be around tomorrow, so it's not necessarily a question directly to yourself. It's to anyone in the audience. I'm not really hearing too much about how age verification technologies are safeguarding young adults who might be neurodiverse, may have learning difficulties, and what are the technological safeguards currently in place? Because this isn't my area of expertise, but I'm just
interested. That's a really good question, and thanks for the question. I think it's something that is not a common question. To be honest, it's the first time that actually I'm questioning this. You're right, because I mean, someone with disability that's 21, 25, all this technology is gonna give the right age, right? I think there's different. I mean, you have accessibility technology for identity verification and onboarding that makes for people with disabilities, for example, if you have hearing problems or vision problems, the technology is able to help these individuals as well to go through different processes of verification. Because even if you have a disability, you should have access to different services through digital onboarding or identity technology, right? But in that, your question is more about if there should be more safeguarding regarding someone with a disability to access specific services that are not that can be harmful to them.
Yeah, particularly say if they may not have mental capacity and they may not have adults around them that help to safeguard them from these technologies.
It's a kind of a general and obvious point in a way. Age, in any event, is only a proxy for capacity. That what the United Nations Convention on the Rights of the Child and most legal instruments actually refer to is the actual child's actual capacity, and that is exceptionally difficult to measure in any event. And the Gillick principle is another example of how it's the individual child's capacity to understand things that is the crucial legal determinant. But in practice, the amount of data that it's necessary to be collected by whoever in order to make a determination on that is huge, and in most contexts on the internet, massively intrusive and potentially very dangerous. You wouldn't want companies gathering all kinds of really personal, intimate information of the kind that might be necessary for them to be able to decide that this is an autistic child or whatever it might be. So I think the short answer to your question is this technology isn't really going to help much for neurodiverse children as such, except to the extent that it guards all children. It won't, not that I'm ever been made aware of, have any particular usefulness or applicability to the smaller minority of children. But the data, by the way, I don't need to tell you this is for the benefit of the rest of the room. The data is overwhelming and clear. Children with particular vulnerabilities, neurodiverse children, children with emotional or learning difficulties are much, much more likely to become victimized in the online environment compared with children in other categories. So it is an issue in our law. The British law, Online Safety Act, says that you're